Hello, everybody, and welcome to lesson 2.5 in your textbook on page, let's make this bigger, page 98. So we're still talking about parallel lines, and this time also mostly about triangles. Parallel lines, as you know, are lines that never cross and never intersect, And in this lesson, we're mostly finding the measures of angles of triangles. So remember, a triangle is a three-sided figure, and we can have scaling triangles where all the angles are less than 90 degrees and different. We can have isosceles triangles where two sides are equal and two angles are equal, and then we can have equilateral triangles where all three angles and all three sides are equal. So any triangle, and the big thing I want to drive across is that because you have three angles in any triangle, this is short for triangle, the sum of all three angles is always 180 degrees. Okay, so if you know two angles in a triangle, you can find the third one. This is angles. You can find the third one. And how do we do that? We're subtracting the sum from 180. Subtracting. I'm just going to leave it as subtracting. Okay, so let's look at our first. We're going to the next page, so we're skipping over to page 99 to the top. This is what I just explained to you. Theorem 16, triangle angle sum theorem. The sum of the measures of the triangles of the angles of a triangle is always 180, no matter how the triangle is shaped. As long as it's a closed three-sided figure, this is the sum. Measure angle A, which would be this angle, plus measure angle B, however much this is, plus measure angle C is equal to 180 degrees. So we're not going to do the proof, but this is super important for you to look at, to remind yourself this is what it's based on most of the lesson, okay? Skip to the next page. And I think we're going to do, okay, I'm going to start with practice 1 first. So we're skipping this one. We're starting here, practice 1, which is on page 100. And it says find the measure, lowercase m means measure, of angle 1. Well, it's a triangle. We have two angles. And I said when we have two angles, we can always find the third. How do we do that? Think about it. Let's see if you can figure it out. Angle 1, that's weird. Oh, here it is. This is a 1. I didn't see that. So we'll add the other two. 10, 1, 4, 5. So the other two, the sum is 150 degrees. And then you subtract from 180 to find the difference, which is 30 degrees. So measure angle 1 is 30 degrees. Okay, that's how you would do that. Now that is a really simple question, and I'm hoping all of you can figure this out. But here we go back to this top question. Look, it gets a little more convoluted, meaning there's more stuff going on. First of all, there are two triangles next to each other. So Actually, there's 3 triangles. If you look, there's this little one here, there's this bigger one here, and then there's the total big one. And so sometimes we have to figure out what's going on in the picture. It says here on the side, plan, which triangle will you use to find the value of Z? It says find the value of Z. Z is right here. So if I look at Z, I notice that in this triangle where Z belongs, I only know one angle, 49 degrees. The other is another letter, that's called a variable. So now I can't find Z because I only know one angle. So I cannot use this triangle here to find Z. Because remember I said I need to know 2 angles to find a third one. So I'm going to look at the other triangle and see if this helps me. And this looks like I can find X because I got 2 angles. This one is 43 and this one is 59. So which, I always like looking at these little side things. I will use triangle ABD because I know 2 angles. And that means I can find the third one. So I can find X first. Measure angle X is 59 plus 43. So I find the sum of the other 2. 59 plus 43 is 12, 1, it's 102. And then I subtract that from 180, which I want to know the difference. 2 to 10 is 8, 1 to 8 is 78 degrees. So I know measure angle X is 78. I'm going to make this bigger. So I put that in my picture, 78. Actually, I'm going to make it a little smaller, 78. Okay, so now I'm playing detective. I know this angle is 78. Now, what if I can find Y? Y belongs to this triangle, which I'm looking for, right? So if I can find Y, then I'm in business. Measure angle Y. And I told you that a straight line, the sum of 2 angles that form a straight line, those are called linear pairs. What do you think the sum is? Do you remember? Linear pair, straight line, the sum is 180, right? Because it's a straight line is 180 degrees. So anytime you have 2 or more angles that make a straight line, when you add them together, your sum is 180. We had that before. So I'm going to say 78 plus Y has to be 180, and I can solve for Y by subtracting 78 from both sides. Oops. This goes away. I saw you guys do your little line. This is excellent. You want to do left side, right side. Whatever you do to one side, you must do to the other side. That's 2, 1, 102. 102 degrees, right? So Y is 102 degrees. I'm almost there because now I'm going to focus on this triangle where my angle Z is that I need to find, right? Okay, so now let's think. Okay, we got 2 angles in this triangle here. How about if I make it green so you see it for sure? So in this triangle, I have 2 angles, 49 and 102. Remember I said if I know two angles, I can find the third one. Measure angle Z. A good habit when you do Z is to put a little line through it, because otherwise it looks like a 2 a lot of times. So students get that confused. Measure angle Z is 49. So I add the other. I add the 2 I know. 1, 5, 151, and then subtract it from 180. And that gives me what's left for the third angle. So that's 1, 6, 8 is 2, 29 degrees. So that was a little trickier. Takes a few steps, okay? Did I do number 2? Okay, let's do that one. All right, this is a good one because it's also asking for a little more. It's asking for find the value of x and y. So let's start with x because I can find x because it's inside the triangle. So then I have my triangle right here. My internet cuts out, then my writing tablet doesn't work. So I have two angles, so measure angle x. You add the two angles you know and subtract from 180. Measure angle x is 80, and I like marking my diagram. So now 70 plus 30 plus 80 should be 180, which it is, but now I have to find y. Well, what's with these two angles? Angle x and angle y are what's called vertical angles. And we have learned that these two angles are equal or congruent. And the symbol for congruent is this. So x and y, they were two lines crossed, the opposites are always equal. So measure angle y is also 80 degrees. And I can put that here. Okay. All right, we're going on to page 101. This is our page 101. We're going to the top. It's called the exterior angle. So now we're learning about angles that are on the outside of a triangle. So notice these inside, but this angle one is on the outside. So exterior angles are formed when you extend one of the sides. So you will have, this is an extension, you can extend this one. That would be an exterior angle. You could extend this side. That would be an exterior angle. So notice, yeah, there's one and there's one. So the exterior angle, there's a connection also. When you exterior, the word exterior means outside, right? If you're on the exterior of a house, you're on the outside of a house, okay? So we got inside, interior angles, and we got exterior angles, inside, outside, yeah? An exterior angle of a polygon. Polygon, by the way, the triangle is the simplest form of a polygon. A polygon is a many-sided closed figure. So you could have 4 sides. That's a rectangle, or no, it's called a quadrilateral. 5 sides. 5 sides is called a pentagon. 6 sides, hexagon. Then it comes septagon, I believe, octagon. It's like a stop sign. So many-sided closed figure. And these rules that I'm showing you are good for most of the polygons. So you can extend it to any, however, the sum of the angles goes up as the sides go up. It's for a triangle, it's 180 degrees. For a four-sided figure, it'll be a 360 degrees. And then you add always 180 degrees for each side, you add more. But that's in another lesson, okay? Right now we're concerned about triangles. So I went on a rabbit trail because polygon is another word for a triangle, okay? It is formed by a side and an extension of an adjacent side. So this is the side, this is the adjacent side. Okay, adjacent means next to. For each exterior angle of a triangle, the two non-adjacent interior angles are its remote interior angles. The verbiage is very confusing. What that means is that this angle one, this exterior angle, and these two are related by these two are the remote interior angles. Remote means far away. So not this one, it's these two. Not this one. So it wouldn't be this one we're talking about. We're talking about these two. So if this is the exterior, it's not the one next to it, it's the one furthest away, remote. If you are living in a remote location, you're far away from everything. So that's what they're talking about here. So the theorem says that the exterior angle is the sum of the two remote interior angles. The sum means if you add this angle and this angle, it equals that angle. So let's look at the way they write it. Triangle exterior angle theorem. The measure of each exterior angle is the sum of the measures of its two remote interior angles. So measure angle 1, the exterior angle, is equal to the measure of angle 2 plus the measure of angle 3. Okay, we're not proving the theorem, but we will use the triangle exterior angle theorem to find angle measures. So we will do that. And I want you to make this a highlight or make it somehow stick out. Put a little thing that says read, pay attention to this. This is where you can remember the information. I want to give you an example. Let me make this picture a little clearer for you. Numbers are sometimes better, giving you actual measures. Let's say this angle here measures 50 degrees. And this one, let's say, I'll just make it 40 degrees. No, it has to be more because I'll tell you why. Let's say this is 60 degrees. So 50 plus 60, you add those two, is 110. So this one would be 110 degrees. You see, add these two, this is what that one turns out to be. Always. Okay, kind of interesting. Okay. And then what are we doing on this page? I'm doing number 3 with you. We're still on the same page, 101. We're going to do number 3. Which of the numbered angles are exterior angles? Definitely not 4. That's not 1. It is 5. We have definitely not 7. We have 6 and 8. Those are exterior angle. Angle 5, angle 8, and angle 6. Okay, I want you to look at that. Name the remote interior angles for each exterior angle. So I'm going to erase that so we don't get confused. I'll start with 8. For angle 8, the remote, it wouldn't be 3 because that's the one right next to it. It would be 1 and 2. Yeah, see how these two are inside the triangle, the furthest away. So for angle 5, I want you to guess, this one is not a remote. This is not an exterior. So for angle 5, This from here to here, which one? It definitely wouldn't be 2 because these two are next to each other. It would be this one and this one. And then we have, oops, we have one more, angle 6. I want you to think ahead, which ones would it be? We're looking for the 2 remote interiors. It's not 3, it's angle 1 and 2. Okay, that's how you find out which ones are the remote interiors. Okay, next question says, how are exterior angles 6 and 8 related? 6 and 8. Oh, these two, 6 and 8, happen to be what kind of angles? Maybe you can come up with a name. 6 and 8 are both exterior angles, not 7, by the way. So they're on the outside and they are at the extension of a leg. Yeah. One of the legs gets bigger or extended, we call it, and it's snugly right there. This one is not it. So they're vertical angles. And the vertical angles are always equal, just remember. I'll just write that as well. Just to remind you, vertical angles are always equal. Okay, next page. We're done with this. Moving forward, we are on page 102. And on this page, I will do pretty much all of them. Kind of fun. So we have, this is an exterior angle, 128.5 degrees. So the picture is kind of small. And it says, find the measure of angle 2. So we want this angle. So here's the deal. This is an exterior angle. These are the 2 remote interior angles. Yeah, not this one. This one is not. That one is attached to that exterior. So angle 2 plus, I'll call it measure angle 2 plus the 13 degrees. This one is 13, is the sum, it's the remote, it's the exterior angle. Sorry, guys. Yeah, the sum of the 2 remote interior angles equals the exterior angle. So here's my equation. So if I call measure angle 2, that's my unknown, I'll call it x, and I leave the degrees off. Then I have to solve this equation. And you guys know how to solve equations by now, I hope. Subtract 13 from both sides. 128 minus 13 is 5. 1 to 2 is 1. And it looks like 115.5 degrees. So measure angle 2. Remember, I substituted that for x. I could have left measure angle 2. That's my unknown variable, what I'm looking for. So that's 115.5, which makes sense. So if I add, to check it, I can say, to check my answer, I can say, okay, 115.5 plus the 13 has to equal the exterior. And it does. If you check it out, use your calculator, it does. Okay. And now let's look for an application. What's this here? What is this? This looks like a tower at an airport, right? Okay. So, oh, I see, there's an airplane. It's landing, flying into the airport. And this is the tower that watches all the air traffic. Very important job. And so what's the question asked? In problem 3, can you find measure angle A? Where is it? Oh, here, this one. Without using the triangle exterior angle theorem. Yeah, yes, yes, yes. Yes, okay, so we're looking for this, we're looking for this angle here, right? Sometimes the green works good on dark. Angle A, there's our triangle. We only have one angle inside the triangle, but these two, so let's find these two. If I add these two, their sum is 80 because this is my remote. No, this is my exterior angle. These are the two remote interior angles. But it says find it without using the exterior angle theorem. So I won't use that. I'm going to do a different way. So I can also say, now I'm sorry if you guys wrote this and I'm erasing it. How about the linear pair? Do you see where you have a straight line here? So these two angles, this one and this one, their sum is 180. So this has to be 100 degrees. 100 plus 80 form a straight line, that's 180. So now I can say, I can use the triangle sum theorem, it's called. The one we learned first on the first page. Okay, this doesn't show good. Okay, so we got 30 plus 100 is 130 degrees, subtract from 180. 50 degrees left for measure angle A is 50 degrees. So there's another way to do this. Okay, so this is important because look, when that airplane comes in, you want to know if they are having the right degrees when they land. If they have if it's too steep, man, you can have a big wreck. Wouldn't want to sit in that airplane. If it's too shallow, it might overshoot the runway. So these angles are important when you fly and land an airplane. Okay. So there's one application, and this one here, a ramp. So we got a ramp. We're going up this ramp. Could be a wheelchair ramp, could be a ramp when you load and unload some trucks that go up to a dock. The ramp forms the angles shown. What are the values of A and B, which are angles, right? A and B are angles, notice, right there. And these two form a linear pair. I want you to look for those things. So these two add up to 180. This is a little clue. This is a 90-degree angle. We need that clue to find angle B. Measure angle B is 90 plus 72. So we're adding these two to find the third angle in this triangle. 2, 7 plus 9 is 62. 60. Did I do that right? 7, yeah. And then subtract that from 180 again to find the interior angle. 2, 8, 1, 18. So measure angle B is 18 degrees, and then we can say, oh, you could find A adding 90 plus 72. So there's two ways to find the angle A. You can use the remote interior angles, which are the 90 plus the 72, or you can use the supplement theorem where you say this one plus this one has to be 180. However you want to do it. 180 minus 18. 2, 162 degrees. Okay, so notice my operations, which operations are the things you can do with numbers, are always adding and subtracting. Multiplying and dividing has not come into play. So your choices are either adding or subtracting these angles. You just have to figure out if it works out at the end. Check your numbers. 162 plus 18 has to be 180, and it is. Okay. And then this one is a weird lawn chair that they used to have a lot in the 60s, but not so much anymore. They're all wood and they kind of fold up really weird. It's a good way to get your finger slammed. But look at the triangle here. Anywhere they can figure out a triangle, they'll use this now. So this is where you're kind of like, and then you have this extension. Now, guess what? This is your exterior angle, right? Angle, exterior angle. These are the two remote interior angles. So the sum of these two is equal to that one. So I'm just writing it out so that you see it again. I haven't even checked the question yet, what they're asking. Measure angle 2 plus measure angle 3. So add these two, you get the third one. Okay, they're giving us numbers, so that's good. A lounge chair has different settings that change the angles. Yep, you could pull that up and then fold it back. So you pull this thing up. Anyway, suppose measure angle 2 is 71. So I'm going to put that number there. And measure angle 3 is 43. What's the measure angle 1? Well, easy. We're going to add these two. 71 plus 43. 4 and 711. 114 degrees. Okay, and now we're done with our lesson. Now you're coming to your homework part. I'm going to urge you to try your very best on the homework and not overlook it, because you need to practice yourself. It is easy to copy the teacher in class. Say, oh yeah, I get it. It is harder when you try it yourself. It is not a problem to come back and say, I tried my best. I could not figure out problem number so-and-so. It is totally wrong to come back and say, I didn't do any of the questions or I didn't understand any of them. That usually tells me you haven't tried. So please try to do at least how much you can, okay? Always refer back to your notes, go back in the book, look at the theorems, look at the examples. All right, so we're on page 103. You're going to do number 13. No, wait, where are we? Oh, this is the wrong page. Sorry, guys. I didn't want to assign this one. I think I'm on the wrong page. We are, this is 102. Yep, we're here. 103. Yep. So this is where your homework starts. And I know you can figure out number 7. Find the measure of the third angle inside a triangle. Yeah, remember how we did that? Number 8, 9. Now 10, I need to show you an example. Okay, this example comes up a lot and I'm really mad that they didn't show that one in the lesson. So if you have a triangle and you have angle measures that involve x, remember anytime you have an x, you have to set up an equation. So let's say my angle and solve, right? So let's say my angles all involve x's. You need to add these 3 expressions and set them equal to 180. Still plow through it. Instead of numbers, now you have variables, 2x plus 1x plus 3x. So this is just an example, right? Yeah. add up 3 angles, the sum is always 180. So now you got to combine like terms. I've noticed a lot of you don't remember how to do that. Put a 1 in front of this one, count them. And the reason is they're on the same side of your equation. So you need to combine them before you move things around from one side to the other. Okay, 2x plus 1x plus 3x is 6x. And then last you divide, division property. 180 divided. So we now know what x is, correct? X is 30. So if you plug in 30 for x, you can find the other angles. Because this is 2x, 2 times 30. So 2 times 30 is 60 degrees. And 3 times x is 3 times 30. This is called substitution. You substitute it back in, plug it back in. That's 90 degrees. Okay, this is an example how you can figure this one out. X and 50. What do they want? Oh, the third angle. 50. You know what? This third one you can't find because we have no way to find x. So your third angle, I'm going to do this one for you. Your third angle is 180. I'll call it question mark. Measure, angle, question mark. You can call it anything. Minus x minus 50. So you're subtracting these two from 180. Well, you can't subtract 180 minus x, but you can subtract 180 minus 50. Those are called like terms. 180 minus 50. So this is your answer. Believe it or not, the measure of the angle you're looking for, the third angle, is this. This is just an expression. Sometimes we have answers involving x. So I'm glad I did that for you. That would have been hard. Okay, next on this page, now we're coming to exterior angle theorem. So I urge you to draw a picture. Angle 1 is an exterior angle, angle 2 and 3. So if you draw a picture, just extend one of the sides, and then 2 and 3 are the remote interior, and angle 1 is your exterior. And now you have the numbers here and here. You can find the third one. And it's for you to figure out. Okay, plug in the numbers into your picture. Same here. You need to learn that you have to draw diagrams a lot of times to help your brain work. It works easier when you look at a picture. So that was 11 and 12. And then 14. There's an error. Oh, this is the one I just showed you, kind of. Remember the x's? Okay, so look at it, and one of them is wrong, and then you have to explain why. And then on the next page, we're on page 105, you're going to do 22 and 23. Those are the hardest ones, but I expect you to try them. You have to set up equations because it's involving x, and solve. And then you have to plug it back in because it's asking for the measure. Find the values of the variables, like x is blah, 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 and then plug it back in to find the actual measure. So let's see who can figure these out correctly. Okay, so that's it. Good luck to you guys.